So we're talking about really evaluating the relative efficiency. So we're not just talking about the relative efficiency of DC, of batteries over AC, direct versus alternating current. We're talking about the relative efficiency of mass events versus micro events, which brings us to a really interesting topic. How do you educate buyers about the differences between energy efficiency, consumption, and the implications with NVIDIA's future rack density? How does all that client education, buyer education come into play so that LS Electric's in there early enough?
Well, so since it's so a couple of things. We actually are under full prototype with technology to support that, and the supporting technology is medium voltage solid state transformers, and also we developed DC digital breakers. So to support all that, and we actually have a couple prototypes already in our near our factories in Korea. In fact, we have a solar field by our frequency drive factory, our variable frequency drive factory that's used majority for VFDs in HVAC. That facility, the solar power is DC, of course. From there, it goes into a battery energy storage system. That's ours. And then this is all kind of combined, controlled. The electronics and the power distribution is kind of going through like a DCE house. If you're familiar with what an E house is, typically, so you have medium voltage, and then it gets moved down to lower voltages throughout the system. So we have a DC to DC converter along with the solid state transformer. We have some vacuum circuit breakers that are all in there. So this is all under prototype testing, and that will actually power the factory that's going to manufacture our drives in Korea. So one of the things, it's up and running right now. It's been commissioned, so I'm hopeful to be able to get some more details on that to share. So that will be a major education, Joshua, to kind of show that here's the technology kind of working. Now, this is not powering a data center, but my point is it's showing taking renewable energy from a solar field, and it could be energy from a solar field, wind, micro nuke, and then of course what we're seeing really take off in the US here right now is gas behind the meter. People like Bloom Energy are their business is going through the roof because with some of the regulation changes in the federal government, now the data center developers can kind of basically can make their own microgrids or power generation. So that's a very positive thing. So that's helping actually move the ball there. So that's great for natural gas, but it's also great for renewable energy. I do find a little ironic twist in the fact that this is also going to be very positive, not only for natural gas, but very positive for solar and other renewable energy for powering data centers. Um, some of the renewable energy may not be big enough to power a whole data center by itself, but it will be plenty big in many cases to have backup power. Especially if they've set up the system where you have a better battery energy storage system, and in lieu of something like a diesel generator, which seems to be one of the biggest issues the public have about data centers, is you have a backup generator that's got diesel, it's noisy and has fumes. I also find it a little ironic that there's many hospitals in many towns in this country that have backup generators that are diesel, and I know that for a fact from my services days for Square D. We did a lot of work in the critical care area, so it's interesting. But I would say, in summary, I think the people that we're talking to now are kind of the large companies, the mega guys that already get the idea that DC is going to be the future, and they're really pushing us on how they feed them information when they're already asking for prototypes and things like that. So in the short term, I don't think there's going to have to be a whole bunch of education in the first phase. The second phase, I think we're already seeing the early adopters are are lining up to get on the boat with DC. That's the short answer. But I think in general, our education of the early adopters is LS understands where this is going, and we have a path to get there. And as we keep moving forward and growing our capacity and refining the product, we'll be there. I mean, if you just think of one thing that really kind of really this kind of blows my mind, to use an old term, is that medium voltage, low voltage, I don't care what kind of transformer you have, the technology there has not really changed in over 100 years. And then all of a sudden now we have solid state transformers that we're looking at, that we're going to be bringing to market in the near future. So it's not lost in me what a technology leap that's happening. And to get the capacities, Joshua, to be able to power and handle the power that we need for large data centers, we're moving. You're seeing the same trend that you're seeing in data centers, where they're getting more capacity and power, going from air cooled to liquid cooled. So yes, so actually our next rev of the solid state transformer will be liquid cooled. So that's another major trend. If you're in the liquid cooling business, and you have a venue to get into the data center world, I think that's a good place to be right now, especially if you have some unique products that are very efficient and savings. On the more PR side for data centers, I think the more data centers that can have their own microgrids, Joshua, and their own power plants is another way to look at it, and be able to say, hey, we're not touching the power of your community. We got our own, so you can stay with your ComEd or whoever your power company is. We're fine. In fact, if we think we're going to generate excess power, we'll be able to sell that, put that on the grid. So we're actually lessen the issue for you guys to have power. So I think on a public relationship education front, not so much for LS, but I think the data center world in general needs to educate the public on a lot of the positive changes that have happened over the last couple of years, and will come down the path that will make communities, happy with tax abatement, employment of skilled trades, and good jobs. May not be millions of jobs, but it's going to be dozens or hundreds of jobs for a data center, depending on how big it is. And then, as from my experience in manufacturing for over 30 years, anytime you have a facility that requires, things that come in and out, you're looking at supporting, for every employee at that facility, you've got 3 to 5 other jobs in the community that help support that. So there's a support structure. So, and I think the single biggest thing that everybody, and I live in Chicago, so I can complain about this a little bit, is taxes. All right. So if you have a data center that comes in and can help with tax abatements so your taxes don't go up, or boy, wouldn't it be great if they went down? I think that's a phenomenal way to look at data centers. It's not as an evil, ugly building, but it's a building that can be a technical resource for your hospitals, your schools, and your in high school, for tech to have better bandwidth. Also, people forget that every time we have our hands on our phone or in front of a computer, and just like we're doing right now, Joshua, we couldn't do this without data centers being able to, take care of handling the traffic over the internet, right? So it's an important tool to help communities grow and have support. So actually our education on what we're doing right now is pretty simple, Joshua, because one of the things, we also make utility grade high voltage transformers. We actually have orders out to 2030 right now, for a very, very large dollar amount going forward. So it's not so much educating people on what we're selling today. It's hey, do you guys know what you're doing? Is it decent quality? You got good engineering front end support. You got good after sales support. including commissioning and repair. And all those are the questions that people are more interested in learning about than so much what the technology is. Because right now UL switchgear is pretty generic in many senses of the word. There's a lot of people. If you look at UL switchgear, like for we use Schweitzer on our packages. That's kind of like an industry standard. We make our own breakers. Molded case, and air circuit breakers and vacuum breakers. In fact, one of the reasons why we have very good deliveries is the breaker factory is adjacent to our switchgear manufacturing in South Korea. And to amplify that and even be closer to the U.S. market, we are now making ACBs and MCCBs in Bastrop, Texas, which is outside of Austin. That factory is up and running. It's also going to be our support hub for the U.S. And we also have a facility out in Utah, which is building medium voltage switchgear. And within a week or two, we're going to be actually moving dirt and starting a construction of 100,000 square foot expansion that we'll be adding low voltage UL gear to. So I think today it's on. If people are looking for how fast can I get it, and are you a company that's going to be around in 3 to 5, 10 years? We've been LS has been around 51 years. And we are really, really growing fast in the U.S. To give you a data point, when I started 7.5 years ago, the first year we finished up about $50 million in the U.S. Last year we were just a little shy of $750 million, and there is a chance this year, depending on what ships, is we might double that this year, Joshua. So just because of the demand in AI is kind of driving the whole market, but it's also been very, very, very good for us because it's allowed people to take a look at other suppliers when they're talking to the other four major brands, and they can't get a good answer on something, or worst case, I'm not going to throw any names out there, but there's been more than one occasion I've heard of people that have placed orders with some of these people and said and paid upfront money to guarantee a delivery, and then it gets pushed back 2 or 3 times, and that's just very frustrating. On the counter to that, we had a very large project in Tennessee with a very semi-famous person who's usually in the arena. And that project, we actually got the initial set of gear there in 4 months, and every month after that, we delivered another chunk of that, and got that all accomplished in about a 9 to 10 month range. And that came from Korea. That was on shipping time and on site. That means when I said it was there in 4 months, it was there in 4 months. So currently on medium voltage and low voltage switchgear, we're talking about somewhere around 40 weeks is we're pretty comfortable as giving as a baseline, and that's after we have everybody's agreed to the specs and the drawings have been signed off and we're ready to go. But one of the things we do ahead of that is, even before the drawings are signed off, if we have a pretty good idea on the buyout items that we don't manufacture, we'll go ahead and place orders on those longer lead time items, because some of those are 16 to 20 weeks themselves. So we'll do that, and that helps expedite the process.